three things that attracted me here. So the first is the depth and strength of the colleagues. So, I've been a student. I was a student at Stanford and MIT, a postdoc at UC Berkeley, and a professor in the University of Wisconsin-Madison. And I can really say that, the research and innovation coming out of the University of Toronto is world-class. So the second thing was the opportunities for cross-disciplinary research. So not only is electrical engineering, computer engineering very strong, but the affiliated departments surrounding us like math and computer science, as well as things like the health sciences. The University of Toronto is a very broad and strong across all schools and all faculties. So that was the second reason. And then I think the third reason is just Toronto itself. Toronto is like this world-class city, great cultural and social opportunities, but also like great opportunities for technology development with like the Mars Development District right around the corner. So I think those were the three things that attracted me. Yeah, so my research is, I basically do the math that makes your cell phones work. So, we're always thinking about how digital communication should evolve 3 years, 5 years, 10 years down the road. And we have to evolve the way we think about how we should conceive of those systems and what needs to change in those systems as we go forward. So, that's basically where my work sits at, where we should push communications technologies to make them accommodate the kind of explosive uptake of mobile technologies and the big proliferation of new applications. So I think, both, obviously I want to make contributions as a researcher myself and also as an educator. I think education is very important in the classroom. We're going through a lot of changes in classroom education, because we have a lot of new tools that are coming out. But also even research itself is an educational process, teaching my graduate students or mentoring them through the dissertation process. And the breadth of work we work on, because of this tight coupling from theory to application, I have students who can push the research themselves. That's what I like to let them. If they're more theory oriented, they can go that way. If they're more practically oriented, they can go that way. Because of this coupling, we can work with the top mathematicians at the top places around the world, but we can also interact closely with industry to make impact, right? So we have ongoing collaborations now with places like IBM, with HP Labs, with Samsung, with Mitsubishi Electric Research Labs, with 3M. My students are doing this summer internships at Facebook, at 3M, at Bell Labs, at Qualcomm. And so they can go out there and really explore these opportunities, and they can, interact with top people from all over the world. And that gives them great opportunities, and it also makes the work we do in the academics important. Yeah, so this one's kind of funny. So I almost didn't become an engineer. So I had a lot of engineering influences growing up. Both my father and my grandfather were engineers. They both graduated from MIT, as did I. So my father worked on satellite systems, digital communication satellites, but also monitoring for like environmental monitoring purposes. My grandfather, Charles Stark Draper, was the head of Aeroastro at MIT, and it was his lab that developed the guidance systems that landed the Apollo missions on the moon. So his technology got the astronauts to the moon and then back home safely. So of course I had all these influences growing up, and engineering. It seemed really cool. I could see like it was a cool field to go into. But then when I got to school, when I was an undergraduate at Stanford, I almost became a historian. So I did 2 degrees. I did a degree in East European history. My thesis was in that. I studied the Balkans. And I also did a degree in electrical engineering. And so I came to this cross point after school about what I would do with my future. And I loved working in the Balkans and meeting the people and understanding the cultures and understanding what had happened and why things were going on there. But in the end, I thought like, engineering was a little more forward-looking for me. There are like a lot of huge issues that are facing the world today. Issues in sustainability and health and energy and infrastructure and kind of security writ large. And engineers, be they electrical engineers or mechanical engineers or civil engineers or teams of engineers, make real huge contributions to making the world the type of world we want it to be going forward. So for me, like, making my own contributions and then also helping to educate that group of people who will make those contributions going forward. That's where I wanted my career to go.